The Buk Missile System (BK) is a family of self-propelled, medium-range surface-to-air missile systems developed by the Soviet Union and its successor state, the Russian Federation, and designed to fight cruise missiles, smart bombs, fixed and rotary-wing aircraft, and unmanned aerial vehicles. The Buk Missile System is the successor to the NDIP Vimepal 2K12 Cube. The first version of Buk adopted into service carried the GRAU designation 9K37 and was identified in the West with the NATO reporting name of Gadfly, as well as the U.S. Department of Defense designation SAR-11. With the integration of a new missile, the Buk M1-2 and Buk M2 systems also received a new NATO reporting name Grizzly and a new DOD designation, SAR-17. The latest incarnation, Buk M3, is scheduled for production. A naval version of the system, designed by MNIIRE Altair for the Russian Navy, according to Jane's Missiles and Rockets, received the GRAU designation 3S90M1 and will be identified with the NATO reporting name Golem and a DOD designation SAR-N7C. The naval system is scheduled for delivery in 2014. Development of the 9K37 Buk was started on 17 January 1972 at the request of the Central Committee of the CPSU. The development team comprised many of the same institutions that had developed the previous 2K12 Cube. These included the Tikhomirov Scientific Research Institute of Instrument Design as the lead designer and the Novata Design Bureau, which were responsible for the development of the missile armament. In addition to the land-based missile system, a similar system was to be produced for the naval forces. The result being the 3S90 Uragan, which also carries the SAR-N7 and Gadfly designations. The Buk missile system was designed to surpass the 2K12 Cube in all parameters, and its designers, including its chief designer Ardalian Rastiv, visited Egypt in 1971 to see Cube in operation. Both the Cube and Buk used self-propelled launchers developed by Ardalian Rastiv. As a result of this visit, the developers came to the conclusion that each Buk transporter erector launcher should have its own fire control radar, rather than being reliant on one central radar for the whole system as in Cube. The result of this move from Telta transporter erector launcher and radar was a system able to shoot at multiple targets from multiple directions at the same time. During 1974, the developers determined that although the Buk missile system is the successor to the Cube missile system, both systems could share some interoperability. The result of this decision was the 9K37-1 Buk 1 system. Interoperability between Buk TELAR and Cube TEL meant an increase in the number of fire control channels and available missiles for each system, as well as faster entry of Buk system components into service. The Buk 1 was adopted into service in 1978 following completion of state trials, while the complete Buk missile system was accepted into service in 1980 after state trials took place between 1977 and 1979. The naval variant of the 9K37 Buk, the 3S90 Uragan, was developed by the Altair Design Bureau under the direction of Chief Designer G.N. Volgin. The 3S90 used the same 9M38 missile as the 9K37, though the launcher and associated guidance radars were exchanged for naval variants. After the 9S90 system was tested, between 1974 and 1976 on the Kashin-class destroyer Provorny, it was accepted into service in 1983 on the Project 956 Sovremeny-class destroyers. No sooner had the 9K37 Buk entered service than the Central Committee of the CPSU authorized the development of a modernized 9K37, which would become the 9K37M1 Buk M1. Adopted into service in 1983. The modernization improved the performance of the system radars, its probability of kill, and its resistance to electronic countermeasures. Additionally, a non-cooperative threat classification system was installed, relying on analysis of returned radar signals to purportedly identify and clearly distinguish civilian aircraft from potential military targets in the absence of IFF. The export version of Buk M1 missile system is known as GANG. Another modification to the Buk missile system was started in 1992 with work carried out between 1994 and 1997 to produce the 9K-37M1-2 Buk M1-2, which entered service in 1998. This modification introduced a new missile, the 9M317, which offered greater kinematic performance over the previous 9M38, which could still be used by the Buk M1-2. The previous 9K-37 series name was also preserved for the complex, as was the Buk name. The new missile, as well as a variety of other modifications, allowed the system to shoot down ballistic missiles and surface targets, as well as enlarging the performance and engagement envelope for more traditional targets like aircraft and helicopters. The 9K-37M1-2 Buk M1-2 also received a new NATO reporting name distinguishing it from previous generations of the Buk system. This new reporting name was the SAR-17 Grizzly. The export version of the 9K-37M1-2 system is called Ural. The introduction of the 9K-37M1-2 system for the land forces also marked the introduction of a new naval variant, the EZH, which carries the NATO reporting name SAR-N7B. Grizzly was exported under the name of Shield, and carries a NATO reporting name of SAR-N7C, Golem. According to Jane's catalogue, the 9K-317 incorporates the 9M317 missile to replace the 9M38 used by the previous system. A further development of the system was unveiled as a concept at EURNAVAL 2004, a vertical launch variant of the 9M317, the 9M317ME, which is expected to be exported under the name 3S90E-SHTIL-1. Janes also reported that in the Russian forces it would have a name of 3S90M, Smerch. The Buk M1-2 modernization, based on a previous more advanced developmental system referred to as the 9K-317, Buk M2, featured new missiles and a new third-generation phased array fire control radar allowing targeting of up to 4 targets while tracking a further 24. A new radar system with a fire control radar on a 24 meters extending boom reputedly enabled more accurate targeting of low-altitude planes. This new generation of Buk missile systems was stalled due to poor economic conditions after the fall of the Soviet Union. The system was presented as a static to display at the 2007 Max Air Show. The export version of the Buk M2 missile system, Buk M2E, is also known as Ural. In October 2007, Russian General Nikolai Frolov, commander of the Russian Ground Forces Air Defense, declared that the army would receive the brand new Buk M3 to replace the Buk M1. He stipulated that the M3 would feature advanced electronic components and enter into service in 2009. The upgraded Buk M3 TELAR will have a 7 rollers tracked chassis and 6 missiles in launch tubes. Description: a standard Buk battalion consists of a command vehicle, target acquisition radar vehicle, 6 transporter erector launcher and radar vehicles and 3 transporter erector launcher vehicles. A Buk Missile Battery consists of 2 TELAR and 1 TEL vehicle. The battery requires no more than 5 minutes to set up before it is ready for engagement and can be ready for transit again in 5 minutes. The reaction time of the battery from target tracking to missile launch is around 22 seconds. The Buk M1-2 TELAR uses the GM 569 chassis designed and produced by JSC MMZ. TELAR superstructure is a turret containing the fire control radar at the front and a launcher with 4 ready-to-fire missiles on top. Each TELAR is operated by a crew of 4 and is equipped with chemical, biological, radiological, and nuclear protection. The radar fitted to each TELAR, referred to as the Fire Dome by NATO, is a monopulse-type radar and can begin tracking at the missile's maximum range and can track aircraft flying at between 15 meters and 22 kilometers altitudes. It can guide up to 3 missiles against a single target. The 9K-37 system supposedly has much better ECCM characteristics than the 3M9 Cube system that it replaces. While the early Buk had a day radar tracking system 9SH-38, its current design can be fitted with a combined optical tracking system with a thermal camera and a laser rangefinder for passive tracking of the target. The 9K-37 system can also utilize the same 1S91 straight flush 25 kW H-band continuous wave radar as the 3M9 Cube system. The 9S35 radar of the original Buk TELAR uses a mechanical scan of a Cassegrain antenna reflector, where the Buk M2 TELAR design used a PESA for tracking and missile guidance. The 9K-37 utilizes the 9S18 tube arm, or 9S18M1 target acquisition radar in combination with the 9S35 or 9S35M1 Fire Dome H-band tracking and engagement radar, which is mounted on each TELAR. The Snowdrift target acquisition radar has a maximum detection range of 85 kilometers and can detect an aircraft flying at 100 meters from 35 kilometers away and even lower flying targets at ranges of around 10 to 20 kilometers. Snowdrift is mounted on a chassis similar to that of the TELAR, as is the command vehicle. The control post, which coordinates communications between the surveillance radar and the launches, is able to communicate with up to 6 TELs at once. The tail reload vehicle for the Buk battery resembles the TELAR, but instead of a radar they have a crane for the loading of missiles. They are capable of launching missiles directly but require the cooperation of a Fire Dome-equipped TELAR for missile guidance. A reload vehicle can transfer its missiles to a TELAR in around 13 minutes and can reload itself from stores in around 15 minutes. Also, the Buk M2 featured a new vehicle-like TELAR but with radar atop of a telescopic lift and without missiles, called a Target Acquisition Radar 9S36. This vehicle could be used together with 2 TELs 9A316 to attack up to 4 targets. Missile guidance in forested or hilly regions. The mobile simulator SAM Buk M2E was shown at MAX 2013. A self-propelled fire simulator installation JMA 9A317ET SAM Buk M2E, based on the mobile, is designed for training and evaluating the combat crew in the war environment to detect, capture, lock onto and defeat targets. A computer information system fully records all actions of the crew to a black box, to allow objective assessment of the consistency of the crew's actions and results. All vehicles of the Buk M1 missile system use an Argon-15A computer, as does the Zaslon radar. It is produced at a Kishinev plant originally named 50 Years of the USSR. The vehicles of Buk M2 missile system use a slightly upgraded version of Argon A15K. This processor is also used in such military systems as Anti-Submarine Defense Corps Shun and SOVA airborne radars for MiG-31 and MiG-33. Mobile tactical missile systems Tochka, Oka and Volga. Currently, Argons are upgraded with the Baguette series of processors by NDIP. Basic missile system specifications: target acquisition range 140 altitude 60 meters 25 kilometers, firing groups in 1 division, up to 6. firing groups operating in a sector 90 degrees in azimuth, 0 to 7 degrees and 7 to 14 degrees in elevation, 45 degrees in azimuth, 14 to 52 degrees in elevation. Radar mast lifting height, 21 meters. Reloading of 4 missiles by TEL from itself, around 15 minutes. Combat readiness time, no more than 5 minutes. Kill probability, 90 to 95%. Target engagement zone aircraft altitude, 15 meters 25 kilometers range, 3 to 42 kilometers tactical ballistic missiles altitude, 2.0-16 kilometers range, 3 to 20 kilometers sea targets, up to 25 kilometers land targets, up to 15 kilometers. Chance to destroy aircraft 0, 7 to 0, 93 maneuvering the aircraft 0.6. In 92, the system has proven the ability to destroy Scud missile R-17 and rocket MLRS caliber of 0.3 meters. Operation The Buk is a mobile, radar-guided surface-to-air missile system with all 4 main components: acquisition and targeting radars, a command element, missile launchers, and a logistics element, mounted on tracked vehicles. This allows the system to move with other military forces and relocate to make it a more difficult target to find than a fixed SAM system. The acquisition radar component allows the system to identify, track and target selected targets. The command component is intended to discern friendly, military aircraft from foes, prioritize multiple targets, and pass radar targeting information to the missile launchers. The missile launcher component can carry a variety of missiles and may be able to engage more than one target simultaneously. The logistics component carries additional missiles and provides other supplies and parts for the system and the operators. In general, the system identifies potential targets, selects a particular target, fires a missile at the target, and resupplies the system. The missiles require a radar lock to initially steer the missile to the target until the missile's onboard radar system takes over to provide final course corrections. A proximity fuse aboard the missile determines when it will detonate, creating an expanding fragmentation pattern of missile components and warhead to intercept and destroy the target. A proximity fuse improves the probability of kill, given the missile and target closure rates, which can be more than 3,000 km per hour. Alternatively, the command component may be able to remotely detonate the missile, or the onboard contact fuse will cause the warhead to detonate. The most capable radar, assuming it has a line of sight, can track targets as low as 30 meters and as far as 140 kilometers. The most capable missile can hit targets as far as 50 kilometers and more than 24,000 meters in altitude. Since the introduction of the Buk in the 1970s, the capabilities of its system components have evolved, which has led to different nomenclature and nicknames for the components' variants. The Buk has also been adapted for use on naval vessels. Integration with higher-level command posts. The basic command post of the Buk missile system is 9-510, 9S470M 1-2 and 9S470 vehicles, organizing the Buk system into a battery. It is capable of linking with various higher-level command posts. As an option, with the use of HLCP, the Buk missile system may be controlled by an upper-level command post system 9S52 Polyana D4, integrating it with S300V, S300VM into an air defense brigade. Also, it may be controlled by an upper-level command post system 73N6ME by Carl-1ME, together with 1 to 4 units of PPRUN1. Integrating it with SAR-19 Grizzon into an air defense brigade, as well as SAR-10 20ths and SAR-5 Gammon and SAR-2 Guideline and SAR-3 Goa and Air Force. With the use of the Mobile Command Center Rangier or Rangier-M, the Buk missile system allows creation of mixed groups of air defense forces. including Tor, Tunguska, Strela-10, and IGLA. CENES is another optional command post for a free mixing of any systems. In addition to mixing their potential, each of the air defense system with the aid of CENES can become part of another air defense system. In Do Not Lose quality, the system works automatically. But for the full realization of all functions, CENES control system is necessary. A few of various other monitoring system for air defense and air force. Otherwise, CENES system will work as a command center but not for free association. 3S90 Uragan M22. The 3S90 Uragan is the naval variant of the 9K-37 Buk, and has the NATO reporting name of Gadfly, and US DOD designation, SAR-N7. It also carries the designation M22. The export version of this system is known as Shtil. The 938 missiles from the 9K-37 Buk are also used on the 3S90 Uragan. The launch system is different, with missiles being loaded vertically onto a single-arm trainable launcher. This launcher is replenished from an under-deck magazine with a 24-round capacity. Loading takes 12 seconds to accomplish. The Uragan utilizes the Mr. 750 top-steer D/E band as a target acquisition radar, which has a maximum detection range of 300 km depending on the variant. The radar performing the role of the 9S35, the 3R90 front dome H/I band tracking and engagement radar with a maximum range of 30 km. Operation 1974 has been tested on the new ship in 1980, adopted in 1983. 3S90 EZH, the modernized version of the 3S90, the 9K-37M1-2 EZH, which carries the NATO reporting name of Grizzly, or SAR-N12, and the export designation Shtil, was developed, which uses the new 9M317 missile. This variant was supposed to be installed on Soviet Ulyanovsk-class nuclear aircraft carriers, and has been retrofitted to the Sovremeny-class destroyers. In 1997, India signed a contract for the three Project 1135.6 frigates with Shtil. Later, when the decision was made to modernize it with a new package of hardware and missiles, the name changed to SHTIL-1. 3S90M SHTIL-1 in 2004. The first demonstration module of the new 9M317ME missile was presented by Dolgoprudny Scientific and Production Plant for the upgraded 3S90M SHTIL-1 naval missile system, designed primarily for the export purpose. Its latest variant used a vertical launch missile which is fired from underdeck silos clustered into groups of 12, 24 or 36. The first SHTIL-1 systems were installed into ships exported to India and China. Old systems Uragan, EZH and Shtil could be upgraded to SHTIL-1 by replacing the launcher module inside the ship. The reaction time is 5 to 10 seconds. The interval between starts is less 2 seconds. To protect against boats, helicopters, aircraft, anti-ship missiles,